a series of equations are given here. They are all nuclear reactions. Some gaps are left in these equations. The purpose of this question is to find out, to fill up these gaps in this. When you look at this equation, namely uranium-235 is bombarded by means of neutron to give rise to two nuclei. That is, one is tellurium and another one is zirconium. So the moment you look at this, this is not a natural radioactive decay, but it is a nuclear transmutation or is a nuclear fission. One important point in doing these equations, considering these reactions, we have to balance these equations. The number of charged particles must be the same. So the answer for this question must be, the equation will get balanced when we have two neutrons added to this. So this will give the molecule on bombardment with neutron on molecule 235 with atomic number 92, the uranium unit, the nucleus, when it undergoes bombardment with neutrons, it fragments, it undergoes a fragmentation or a nuclear fission to give these two nuclei, releasing two more neutrons along with this. So the first answer to this question is two neutrons. Now let us go to the next question. Selenium. This selenium-86 undergoes a change, releasing, it looks like a beta decay because two electrons are being released. So what will be the resulting nucleus? The resulting nucleus is actually is krypton, which is 82, the atomic number is 34. Because as we know, selenium is 34, when it loses two beta particles, atomic number goes up by 2 units, which is 36. And there is no change in the mass actually. Therefore, you will find, and this is actually what is obtained is krypton. So this is a beta ray decay. The third one is, there are two gaps in this equation. This is only a beta emission from the nucleus of the compound. Actually, this should be 86 because selenium-86 undergoes a beta decay giving rise to krypton of the 36. The atomic number goes up by 2 units because 2 electrons are lost, but there is no change in the mass. Therefore, the equation to be balanced, krypton should have an atomic mass of 86, which is the same as the selenium. Now coming to the third equation, uranium undergoes some reaction, some nuclear reaction, changes over to uranium-238, changes over to 239. Therefore, there is an increase in the mass of 1 unit. So probably it can be 1 neutron. There is no change in the charge. So it becomes 92. But this again undergoes a change over to 1 more unit. The atomic number increases from 92 to, this remains as 92. There is no change in the atomic number, but there is only a change in the atomic mass, increase in the atomic mass from 238 to 239. Whereas in the second set of the equation, uranium-92 changes over to uranium-93. That means it undergoes, it increases in the atomic number from 239, but the mass remains the same. Therefore, it should be an electron or a beta ray. So this is how the gaps are being filled up. The equations must be balanced as we look at these equations. There is, in terms of mass as well as in terms of charges, the equation must be totally balanced.